A systems-based reassessment of modern disease, obesity, and longevity. Abstract modern medicine has achieved extraordinary success in acute care, infection control, and life extension. Yet chronic disease, obesity, metabolic dysfunction, and age-related decline have increased dramatically over the same period. This paper argues that these trends cannot be adequately explained by traditional single-factor models such as caloric excess, sedentary behavior, or genetic predisposition alone. Instead, they are best understood as emergent consequences of systemic biological disruption, with the human microbiome acting as a central regulatory layer influencing metabolism, immunity, inflammation, cognition, and aging. By synthesizing evidence from microbiome science, aging biology, epidemiology, and metabolic research, this paper proposes that many modern health challenges arise from ecological imbalance rather than individual failure, and that future progress depends on restoring biological resilience rather than pursuing narrowly targeted intervention. 1. Introduction: the limits of reductionist health models. For much of the 20th century, medicine advanced through reductionism, isolating pathogens, targeting organs, suppressing symptoms, and correcting biochemical abnormalities. This approach remains indispensable for acute and emergency care. However, it has proven insufficient for explaining or reversing the rise in chronic, multifactorial conditions such as obesity, type 2 diabetes, autoimmune disease, neurodegeneration, and accelerated aging. The dominant public narrative, that poor health primarily reflects lifestyle choice, overconsumption, or lack of discipline, is increasingly inconsistent with biological evidence. Individuals exposed to similar diets and environments often display radically different health outcomes. Such variability demands a systems-level explanation. 2. Humans as meta-organisms. Humans are not biologically autonomous. We are meta-organisms, composed of human cells and a vast microbial ecosystem that includes bacteria, archaea, fungi, and viruses. Microbial cells outnumber human cells, and microbial genes outnumber human genes by orders of magnitude. The microbiome is not a passive passenger. It actively regulates energy extraction from food, trains and modulates the immune system, produces metabolites essential for gut, vascular, and brain health, influences hormonal signaling and appetite regulation, maintains or disrupts intestinal barrier integrity. From this perspective, health is not merely the absence of pathology but the maintenance of ecological stability within a complex biological system. 3. Weight gain as biological regulation, not moral failure. One of the clearest implications of a microbiome-centered model is the reframing of obesity. Body weight is not consciously controlled, it is biologically regulated. Food intake and physical activity are inputs, but the body determines how efficiently calories are harvested, whether energy is stored or dissipated, how hunger and satiety are perceived, how fat is distributed. The microbiome plays a decisive role in all of these processes. Distinct microbial communities extract different amounts of energy from identical foods and generate signals that influence insulin sensitivity, inflammation, and appetite hormone. This explains why weight gain varies dramatically between individuals. Long-term weight loss is difficult to maintain. Exercise alone often fails to reverse obesity. Relapse after caloric restriction is common. In this light, obesity is better understood as a state of altered biological regulation, not a failure of willpower. 4. Antibiotics, the microbiome, and the obesity epidemic. One of the most compelling yet under-acknowledged contributors to modern metabolic disease is widespread antibiotic exposure. Since the 1950s, low-dose antibiotics have been used in livestock to increase growth rates, improve feed efficiency, promote fat deposition. The mechanism is microbial. Antibiotics reshape gut ecosystems in ways that increase energy harvest. This practice is not controversial in agriculture, it is foundational. Human data reveal troubling parallels. Early life antibiotic exposure correlates with increased obesity risk. Repeated courses reduce microbial diversity long-term. Dysbiosis promotes inflammation and metabolic dysfunction. While antibiotics remain indispensable, their population-level metabolic consequences were never anticipated. The timing of mass antibiotic use aligns closely with the rapid rise in obesity and chronic disease, suggesting an unintended large-scale biological experiment. 5. Why this explanation faces resistance. A microbiome-centered model challenges deeply embedded assumptions. It undermines personal responsibility narratives, implicates medical overuse and industrial food systems, shifts accountability toward policy and regulation, complicates prescribing decisions and agricultural practices historically. Similar resistance accompanied evidence linking smoking, trans fats, and leaded petrol to disease. Paradigm shifts that redistribute responsibility evolve slowly. 6. Aging and the Hallmarks Framework. The hallmarks of aging describe reproducible biological processes associated with aging, including genomic instability, epigenetic drift, mitochondrial dysfunction, cellular senescence, and immune dysregulation. As a descriptive framework, the hallmarks are robust. However, they are frequently misinterpreted as a checklist for intervention. Many aging mechanisms evolved as protective trade-offs. Cellular senescence suppresses cancer, inflammation enables defense and repair, growth suppression conserves energy. Aggressively targeting individual hallmarks risks destabilizing the system as a whole. Aging is not a single enemy to be defeated but a negotiated balance between protection and decline. The most reliable way to slow aging is not radical repair, but damage rate reduction and resilience preservation, precisely the domains influenced by metabolic health and microbiome stability. 7. Healthspan versus lifespan. Current evidence strongly supports the extension of healthspan, the years of life spent in good physical and cognitive function. Claims of dramatic lifespan extension or rapid biological rejuvenation remain speculative in humans. Improvements in biological age markers, such as epigenetic clocks, are informative but do not yet demonstrate deep reversal of aging processes. The realistic and meaningful goal is compression of morbidity, not immortality. 8. BMI, metabolic health, and cancer risk. Maintaining a healthy mid-range body mass index, particularly when paired with good metabolic health, confers substantial protection against several cancers. Excess adiposity increases cancer risk through chronic low-grade inflammation, elevated insulin and IGF-1 signaling, increased estrogen production, impaired immune surveillance. BMI itself is an imperfect proxy. Visceral fat, insulin sensitivity, inflammatory tone, and muscle mass are more mechanistically relevant. Nonetheless, leanness remains one of the strongest non-pharmacological cancer protective factors known. 9. Personalized nutrition, longevity advocacy, and limits of optimization. Personalized nutrition platforms and high-profile longevity experiments have value in increasing engagement and improving short-term metabolic markers. However, their greatest contribution is behavioral rather than predictive precision. Extreme optimization strategies demonstrate what is possible under tightly controlled conditions but do not yet constitute generalizable or low-risk solutions. Long-term resilience likely depends more on diversity, adaptability, and moderation than on maximal suppression of biological variability. 10. A unified systems perspective. The most defensible synthesis of current evidence is most modern chronic disease, obesity, and accelerated aging arise from systemic ecological disruption, particularly of the microbiome, interacting with genetics, environment, and immune history. Food quality matters. Exercise matters. Medical intervention matters. But biology determines how these inputs are interpreted. Conclusion: the microbiome-centered view of health does not reject modern medicine, it completes it. It reframes disease not as moral failure or isolated pathology, but as loss of biological coherence. Weight is regulated, not chosen. Aging is negotiated, not programmed. Health is ecological stability over time. Recognizing this shifts medicine from blame to prevention, from suppression to resilience, and from isolated fixes to systems stewardship. This perspective is not fringe, it is simply ahead of consensus.